Welcome to Mathematics. Today we're gonna do the integral of ln(x) over x power 4 minus 1 going from 0 to infinity. This integral seems like it's really crazy, but it's not too crazy at all. I will show you. X power 4, you can write this as x squared and then square, right? And the minus 1 square, you can just factor it out as this, right? ln(x) over x squared minus 1 times x squared plus 1 dx, like that. So over, we're going to use our partial fraction here and consider 1 over that. 1 over x squared minus 1 times x squared plus 1. I'm going to split to two different fractions, like x squared minus 1 plus x squared plus 1. And on the top, what should we put on the top? Just look at this. This denominator look as the power x squared. You need one less power, just ax. Don't forget to plus b. And here is cx plus d. So multiply by this on both sides, you will get 1 is equal to ax plus b multiplied by x squared plus 1 plus cx plus d multiplied by x squared minus 1, like that. So overall, just distribute it, you get x power of 3, a times x power of 3, and then plus ax, and then this time that becomes b times x squared is b x squared plus b, and then this time that cx cubed minus cx plus dx squared minus d. And here's still, I would like to combine the terms like x cubed, x squared, and then x and constant. Let me just combine the x cubed term. Look at this, ax cubed and then cx cubed. Let me combine to a plus c, right? A plus c multiplied by x cubed, like that. And look at square. X squared, we have bx squared, and then we have positive dx squared, like that. Then we combine to b plus d times x squared, like that. And positive ax and then negative cx, it becomes a minus c times x, and then the constant part is just b minus d, like that. And then you can compare the coefficients of both hand sides. You can get a plus c is equal to 0, then b plus d is equal to 0, and then a minus c is equal to 0. However, the only one is different is just b minus d is equal to 1, just because of the constant part. So other ones are all equal to 0 except for b minus d. So we're going to do the linear equations. So the first one is really easy. Look at a plus c is equal to 0. A minus c is equal to 0. If you want, let me just write down the answers to you guys. A is equal to 0, c is equal to 0, like that. You can do these two equations by adding them up. You get 2a is equal to 0, because c and negative c, they are cancelled. And then a is just equal to 0. And then put a is equal to 0, you can guess c is also gonna be 0. So if a plus c needs to be 0 and then a minus c needs to be 0, they both need to be 0, like that. So b plus d b plus d is equal to 0, and then b minus d is equal to 1. Let me just add them up. So d and negative d, they will be cancelled, so you can get 2b is equal to 1. Sorry. So 2b is equal to 1, so we can get b is equal to 1/2. And then put that 1/2 into it, you get d is just equal to negative 1/2. So you can just put it back in. So you pretty much just multiply by ln(x) here. So we can also just put the 1/2 outside. So let me split to two different integrals, like that. X squared plus 1, and this is x squared minus 1 dx, like that. So we have 1/2 because a and c, they both equal to 0, so our b is just 1/2. The constant on x squared minus 1, the numbers is just 1/2. So I may put a 1/2 in the front and then multiply by ln(x), right? Both of them need a ln(x) on the top. So here just multiply by -1/2, like that. So I'm going to erase this partial fraction here. I think this integral is kind of hard. Not so simple at all, because we need to use some partial fraction. And here's the deal, like that. Here, I'm going to look at this integral first. The integral of ln(x) over x squared plus 1 going from 0 to infinity. Let me just tell you, this integral is just equal to 0. You can let x is equal to 1 over t and then do more work. You get the negative version of this, and then you add the negative version and the original version. You will get the entire integral is just equal to 0. You can also let x is equal to tangent theta. So this over, you just get tangent theta here, and then dx is equal to secant square theta, and this they will be cancelled out. So you are going to do an integral of ln of tangent theta from 0 to the power of 2. So this integral is gonna be 0 as well. So look at this integral, ln(x) over x squared minus 1. I would like to use this formula. So this is the integral of ln(x) over x squared plus a squared dx, going from 0 to infinity. You can check my older video. I already do the integral of this. So you can let x is equal to a tangent theta to keep doing this integral, and then this integral, the answers to this is just pi times ln a divided by 2a, and that's. So we have a -1 here. I would like to get something positive. So how can we get -1 and then get a positive? We can use I squared. You know, I squared is equal to -1, right? And we can get a negative, just get a positive sign here. So the integral of ln(x) over x squared plus I squared. So we can just apply this formula, because this I just match the a. So overall you just get pi times ln I divided by 2 times I, like that. So overall you get pi over 4 here. And then what is ln I though? And ln I, let me just tell you, the answers of this is just pi over 2 times I. You should memorize this. Pi over 2 times I, and I already explained this ln I on my video. So I'm going to just put down the pi over 2 times I here, and then I divided by I, like that. So you pretty much just cancel the I. So ladies and gentlemen, you pretty much just get pi times pi is pi squared, and then 4 times 2 is just pi a. So the answer is just pi squared over a. How cool is this?